Yeah, welcome back to this channel. So today we want to find the y dx if y is equal to cos x by the use of the first principle of differentiation. So let's go. Solution. The first principle of differentiation can be defined as dy dx is equal to the limit as change in x tends to 0, then f of x plus change in x minus f of x divided by change in x. So our f of x is the same thing as y, which is equal to cos x. So f of x plus change in x will now be equal to cos of x plus change in x. So we need to substitute everything inside this formula. The limit as change in x tends to 0, then cos of x plus change in x, then minus cos x divided by change in x. And recall, if you know trigonometry identities very well, you must have been familiar with this. Cos of a plus b is equal to cos a cos b cos b minus sine a sine b. So it's the same thing as the cos of x plus change in x, which is equal to cos x cos change in x minus sine x sine change in x. So we're going to substitute that inside this formula. So dy dx is now equal to the limit as change in x tends to 0, then cos x cos change in x minus sine x sine change in x, then minus cos x. Everything divided by change in x. So from here, let's collect like terms. So dy dx will now be equal to, so we can say cos x here, we can also say cos x there. So we can match them together. So cos x cos change in x minus cos x, then minus sine x sine change in x, everything over change in x. So let's factorize cos x out. So don't forget to put your limit as change in x tends to 0. So dy dx now be equal to the limit as change in x tends to 0. So cos x into bracket cos change in x minus 1 minus sine x sine change in x over change in x. So from here we can say dy dx is equal to the limit as change in x tends to 0, then cos x multiplied by cos change in x minus 1 over change in x, or close the bracket, then minus sine x into bracket sine change in x over change in x. So now from here, you have to recall from limits that the limit as x tends to 0, then cos x minus 1 over change in x over x, over x is equal to 0. And also the limit as x tends to 0, sine x over x is equal to 1. So it's the same thing. So we now say that the y, that means wherever we see cos change in x minus 1 divided by change in x, their limits Or let's do it this way. Dy dx will now be equal to cos x, then limit as change in x tends to 0, then cos change in x minus 1 over change in x, then minus sine x, then the limit has change in x into bracket sine change in x over change in x. So it means that wherever I see the limit as change in x tends to 0 over cos change in x minus 1 divided by change in x, then I'm going to put 0 there. So wherever I see the limit as change in x over sine change in x over change in x, I'm going to put 1 here. That is the limit. So the y dx will now be equal to cos x, then multiply by 0, then minus sine x multiplied by 1. Anything multiplied by 0 will give us 0. So invariably the y dx will now be equal to minus sine x. So that is how the y dx of cos x is equal to minus sine x. So till I see you in the next class. Thank you and God bless you. Bye bye.